Hi everyone! In this video we're going to learn how to identify and classify isomers. So last time we talked about the different types of isomers. There are constitutional isomers and stereoisomers. And then within stereoisomers there are enantiomers and diastereomers. So for the following compounds below, we're going to draw all of the isomers, and then we'll determine whether those isomers are chiral or achiral. If an isomer does have a stereocenter, we're going to designate it as R or S, and then we'll determine the relationship between pairs of isomers. So we'll determine if they're constitutional isomers, enantiomers, or diastereomers. So in this video, we're just going to focus on these first two molecules, and then in the next video, we'll focus on the last two. So this video, and this will be for the next video. Okay, so let's start with number 1, and we'll do this one together. All right, so C3H9br. Okay, so again, we're going to draw all of the isomers for this compound. Now, we only have 3 carbons, so I'm just going to start by drawing the 3-carbon chain. And then we have a bromine somewhere on this carbon chain. So where could we put that bromine? Well, we could put it on one of the 2 end carbons, right? I'll just put it arbitrarily on this one. And then if we had put it on the left-hand side, it would still be identical to this molecule. So it doesn't really matter which one we put it on. And then is there anywhere else we could put the bromine? Well, we could put it on the middle carbon. Okay, so those are our 2 isomers for C3H9br. Let's actually name these 2 compounds. So let's name the first one on the left. So first we have to identify the longest carbon chain. So we already said that we have 3 carbons. So which prefix would we use to say that we have 3 carbons? Meth, eth, prop, but, pent. What would we use? Prop. So this will end in propane. And then our substituent is bromine. So we would call that bromo. And which carbon is bromine on? So remember, we want to make sure our substituent has the lowest number possible. So you might be tempted to number this molecule from left to right. So 1, 2, 3. But that means bromine would be on the 3rd carbon. So remember, we could also number these 1, 2, 3 from right to left. And then bromine would be on the 1st carbon. So we want to number this from right to left. That will give bromine the smallest number possible. So this is 1-bromopropane. All right, now what about our second molecule? How would we name that one? So the name will be really similar. Again, we have a 3-carbon chain and a bromine substituent. So it looks like the only difference is the carbon that it's on. So we would number this 1, 2, 3, and it doesn't really matter which way we number it because the center carbon will always be carbon 2. So this will be 2-bromopropane. Okay, so now let's try to figure out whether these molecules have stereocenters. So let's look at 1-bromopropane. Does that have any stereocenters? Another way to ask that question, do any of the carbons have 4 different bonds? Nope. You might be tempted to say that carbon 1 has 4 different bonds, but remember, it's bonded to 2 hydrogens. And those 2 hydrogens are the same, so that disqualifies carbon 1 as a stereocenter. So there are no stereocenters on that molecule. What about 2-bromopropane? Are there any stereocenters? So you might be tempted to say that carbon 2 is a stereocenter, but it's bonded to a methyl group on the left and a methyl group on the right. And those two are the same type of carbon or the same type of group. So that disqualifies carbon 2 as a stereocenter. So there are no stereocenters. Oops, stereocenters. All right, so then are these molecules chiral or achiral? Well, if they don't have stereocenters, then they are achiral. Okay, so the fact that they are achiral will tell us more about their relationship to each other. So are these two molecules constitutional isomers? Are they enantiomers? Or are they diastereomers? So these are constitutional isomers. So they have the same molecular formula, but they have different connectivity. Okay. Now let's look at our second molecule, C4h9br. So I would like you to try this one on your own. See if you can draw all of the different isomers for C4h9br. I would also like you to try to name them. And sometimes naming a molecule will also show if it's identical to a previous molecule that you drew. And then see if any of your molecules have a stereocenter. And if it does have a stereocenter, assign R and S to it. So pause the video, try it on your own first, and then we'll go over it together. Okay, so let's draw the different isomers of C4h9br. So the first thing I'm going to do is just draw a 4-carbon chain. And there's a couple different places we could put the bromine substituent. We could place it on the end of our molecule. And you could have put it on the other carbon on the left, but I just drew it on the right. And then the other place we could put the bromine is on the second carbon in the chain. Now, if we put that bromine on the third carbon in the chain, remember, we have to make sure it has the lowest number possible. So it would end up on carbon 2 anyway. So let me just draw that to show you what I mean. So if we put bromine on the third carbon, it's really still just on the second carbon, right? Either way, from left to right, that's the second carbon. So that's just the same exact molecule. You can also build these using a modeling kit to see if they're the same or different. And remember, you can rotate the molecules any way you need to in order to prove that they're the same or different. Okay, so now is there any other way that we could maybe draw the carbon atoms? So instead of in a chain, maybe we have 3 carbons in a chain, and the 4th carbon is in a methyl group. Well, we still need a bromine somewhere. So let's put bromine on the end of the molecule. And again, it doesn't really matter if we put this on the left or the right end of the molecule. Let's see, and then if we draw that same pattern of carbons, we could put bromine in the center. Okay, so those are our 4 different isomers of C4h9br. And there really isn't any other way that we could draw the structures since we only have 4 carbons and 1 bromine. All right, now let's go through and name each of these molecules. So let's start with the first molecule that we drew. So if we have 4 carbons in a chain, which prefix should we use? Meth, eth, prop, bute, pent? We could keep going. Bute. So butane tells us that we have 4 carbons in a chain. And then again, our substituent's bromine, so we would write bromo. And then which carbon is bromine on? Carbon 1. So this is 1-bromobutane. Okay, what about our second molecule? How would we name that one? And I'm talking about the one on the upper right. So that one's pretty similar. We have bromobutane. The only difference is bromine is on a different carbon. So what number carbon would that be? Carbon 2. So remember, we want bromine to have the lowest number possible here. So we don't want to number that carbon as carbon 3. We want it to be carbon 2. Okay, now our molecule on the bottom left, how do we name that one? So let's see. Let's find our longest carbon chain. 1, 2, 3. And then we have a methyl substituent and a bromine substituent. All right, so how do we name the longest chain? Is that meth, eth, prop, bute, pent? Prop. So it would be propane. Now we have 2 substituents this time. We have a methyl group and a bromo group. So we have to alphabetize them. So which one would come first, bromine or methyl? Bromine. Okay, so we would write 1-bromo and then 2-methyl. So this is 1-bromo, 2-methyl propane. All right, and then what about our last molecule? What is our longest carbon chain? 3. And in this case, it doesn't really matter which way we number the carbons, left to right or right to left. We still end up with our substituents on the second carbon. Okay, so this would, oops, this would also be propane. And then we have, again, a methyl group and a bromo group. And we've said that bromo would come first. So this time we would have 2-bromo dash 2-methyl. Okay, so we've named each of the molecules. Now in the next step, let's figure out if any of these molecules have stereocenters. So let's look at 1-bromobutane first. Are there any stereocenters there? Nope, this is similar to 1-bromo propane. We might be tempted to say that this carbon attached to bromine is a stereocenter, but remember it's bonded to 2 hydrogens there, so that disqualifies it. So is that chiral or achiral? It is achiral because it does not have a stereocenter. Okay, what about 2-bromobutane? Does that have any stereocenters? Yes. The carbon bonded to bromine is bonded to 4 different groups. There's an ethyl group on the left, a methyl group on the right, a bromine, and then a hydrogen that's kind of hiding back there. So we have 4 different groups on that carbon. So is that molecule chiral or achiral? It is chiral. All right, let's look at 1-bromo, 2-methyl propane. Are there any stereocenters? So you might be tempted to say that carbon 2 is a stereocenter, but it's bonded to a carbon up above and a carbon off to the left that are both bonded to 3 hydrogens. So those are actually the same groups to the left and up above. So that carbon is not a stereocenter. And then it might also be tempting to say that carbon 1 is a stereocenter, but again, remember that that is bonded to 2 hydrogens. So that is also not a stereocenter. So is this molecule chiral or achiral? Achiral, because it does not have any stereocenters. All right. Now let's look at 2-bromo, 2-methyl propane. Are there any stereocenters in that molecule? So again, you might be tempted to say that carbon 2 is a stereocenter, but notice these 3 carbons that it's bonded to, they're all the same. They're all bonded to 3 hydrogens. So it is not a stereocenter. So would this be chiral or achiral? It would be achiral. All right, so Our only chiral molecule is 2-bromobutane. Okay, so let's draw the molecule and its mirror image and see if they're superimposable. So I'll do that up above. So I'll draw this as a wedge, just arbitrarily. And then I'll draw its mirror image. Okay, so are those superimposable? So what if we flip the mirror image? What if we flip it over like a pancake? Let's see, I'm going to make some room down here. If we flip it over like a pancake, then it would look like this. So the wedge becomes a dash. So is that superimposable on our original drawing? No, because one is a wedge, one is a dash. All right, so I'm going to redraw these and we're going to assign R and S. Okay. Now, because these are non-superimposable mirror images, that means that they are enantiomers. So remember from our definition of enantiomers, they have the same molecular formula, the same connectivity, but they are non-superimposable mirror images. And they have different three-dimensional structures. All right, so let's start with the 2-bromobutane that's on the left, and let's assign R or S to it. So we have to prioritize our groups that are bonded to that stereocenter carbon. So that carbon is bonded to a bromine on the bottom, an ethyl group on the left, and a methyl group on the right. And then there's a hydrogen also hiding in the back. So which would come first, bromine, carbon, or hydrogen? Bromine, it's the heaviest atom. Next, we have competing carbons. We have one on the left and one on the right. Which one would have second priority, the ethyl group carbon or the methyl group carbon? The ethyl group carbon, because that carbon's bonded to another carbon, but the methyl group carbon is just bonded to 3 hydrogens. So the ethyl group carbon would win. Okay, now luckily our lowest priority atom is in the back, so we don't have to worry about flipping our assignment. And if we draw an arrow from 1 to 2 to 3, would that be going to the right in a clockwise direction or to the left in a counterclockwise direction? So that would be going to the right in a clockwise direction. So is that R or S? R. All right, so that carbon is R. What about the one on the right-hand side, so on our other molecule, on the mirror image, let's do the same thing. So the priorities would be the same. Bromine would be number 1, the ethyl carbon is number 2, the methyl carbon is number 3, and then we have a hydrogen in the back. So again, we're going to draw a circle from 1 to 2 to 3. And is that going towards the right in a clockwise direction or to the left in a counterclockwise direction? To the left. So would this be R or S? S. Okay, so we actually have two different molecules here. So the way we would name these is one of them is 2R-2-bromobutane, and the other one is 2S-2-bromobutane. So we have 2S-2-bromobutane and 2R-2-bromobutane. All right, so now let's figure out the relationships between all of these compounds. So we said that the 2S and 2R bromobutane, those are enantiomers. But how do those relate to 1-bromobutane? So those would be constitutional isomers. In fact, that would be the case for all of these. So these are all constitutional isomers except for 2S and 2R-2-bromobutane. Those are enantiomers up above. Okay, so I hope that helped a little bit with understanding the difference between constitutional isomers and enantiomers. In the next video, we're going to do the same thing that we did today, but we're going to focus on the last two molecules. So I will see you in the next video.